This is problem 70 from the textbook, and we're going to get started. So sine squared minus tan theta over cosine squared minus cotangent theta. So next we're going to do problem 84 and then 86. For this problem is to rewrite this one, we'll start off with the left side as the given, as sine theta over cosine theta. And the first thing that I see, I think it would be a good idea to, and then rewrite a couple different options, but maybe that sine theta minus sine cubed theta, cosine theta, kind of stands out. You don't see sine cubed very often. I'm going to see if I can find a way. If I factor, so for just that we the sine theta out of sine cubed and sine theta. So a little GCF. Then we're going to need common denominators to combine the fractions on the top. It's kind of a clever way to start the two terms on the top. Might be a good idea to pause right now that you've seen this and try and finish on your own. Just this initial first step might be enough to get you started. And so we'll call this factor. This fraction will need to be multiplied by sine theta. And then hopefully you recognize that 1 minus sine squared. After we do that, and you combine the fractions in one step here, we will get sine squared. So 1 minus sine squared came out, and cosine squared came in, times cosine theta. And then this is all over sine minus sine theta. So that was Pythagorean divided by cosine theta. Then at some point you're going to have to figure out how to break this into two different fractions that are adding together, because the initial problem has cotangent theta minus cosine squared theta, which means that you need two separate terms, and this is only one term. So I'm going to split this up. So it would be a good idea to stop the video periodically and try and finish on your own, rather than just letting me do all the work and you copying it down. I can use kind of the distributive property, allows me to rewrite these as each being divided by sine theta. The distributive property works for multiplication, and now I'm going to simplify this complex fraction by multiplying by the reciprocal and be used for division. So I have this term here and this term here, and being each divided by sine theta. You can tell this works because if you put them back together again, they have common denominators, and you would get right back to this. So this is separation of terms. I can tell I'm on the right track because I have a sine theta over a cosine theta, which I know is equal to tan theta, and I'm trying to get to tangent squared. So now this cosine over sine is cotangent in the right direction, even though this still looks very complicated. At this point you probably feel pretty stuck, but this numerator here has its greatest common factor, and this denominator here also has the greatest common factor. It's fairly complicated, so it's hard to see what it will look like when it's factors. Quotient, you just have to trust it, simplify, and see what happens if you try it. If it doesn't work, you might have to start the whole thing over again and use a different that wasn't the only way to do this problem. I think you also could have separated from the beginning both terms. So this is being sine squared. This on your own turn back into just sine theta. You could have taken this. This would be 1 initial problem and said cosine theta over sine theta, and this is sine theta plus sine theta over sine theta, and then this has a cosine in both terms, minus so I'm going to factor out the cosine cubed theta, and after I do that I get cosine, and again that would be the distributive property. If the whole quantity is divided by sine theta, then each can be divided by sine theta, and then you could get cotangent times cosine theta plus 1 minus the sine squared theta as cosine theta sine, and the sine squared theta becomes cosine squared. So those cancel. So there's an alternate way of starting off this problem without completing the whole thing. Which is tan theta. Alright, so let's look at number 86 now, which is tan theta. Got this here. So I think this problem might be easier by starting on this side. So here I just simplified tan theta minus cotangent theta. instead of on the left
And
side.
here
And there's no rule that says you
I
can't do
factored.
that. So instead of starting there,
And
I
also
get rid of this.
simplified. Here I use
And
the quotient rule.
bring this down as our given. And here I simplified or multiplied. Let's see how that works. So, alright, so that one's done. That was pretty hard, I'd say. I'd rate that as a hard level one, particularly because the factoring right here is pretty hard, and recognizing that you have a greatest common factor was key to being able to do this problem.
Cosine theta over sine theta.
Alright, so let's check out this one over here.
Both quotient.
Get all of this out of the
identities.
way. So now we need a common denominator, which you're probably, hopefully getting better at that concept and seeing how it works.
And
so this fraction will have to be multiplied by cosine over,
so
by
here's
sine
the given.
over sine. This is number 83.
So we'll
Get sine squared minus and
cosine squared.
We have
by making
cosine squared minus sine squared over 1 minus tangent squared.
If you're
So
not sure
I think
how
it's
did
probably
that,
a good
I took
idea
this one
and
and
keep the
multiplied by
cosine squared
cosine
minus sine squared over cosine. And
this
then
one
we have 1 minus
sine
sine squared. Now remember, I'm trying to get to this because I started with the right side. I'm trying to change it to the left side.
And I think we should make
I'm actually almost there.
in the
Sine cosine on the denominator. And then I just need 1 minus 2 cosine squared up here. So I don't need the sine squared. And so I'm going to take out the sine squared. And
this is cosine
and replace it with
theta
1
minus
sine squared
cosine
squared
over
cosine minus cosine squared theta all over sine theta squared cosine theta all divided by that is Pythagorean squared theta. That was by taking,
and so you get
1
fraction
here
2
and multiplying it by
squared theta
all divided by sine
squared
theta over cosine theta squared theta. Then I have this common denominator, and I just wrote it as a single fraction here. So we'll call this common denominator. Alright, so it's done. I think it's definitely easier starting with the right side and going to the left. Most of the problems in the textbook have not been easier going in that direction, but you are always allowed to do that. You just have to start on one side and apply known identities to get to the other side. But what if you didn't think of that and you tried to do it starting on the left? Multiply that by let's just see what squared theta you might be able to come up with over that. Cosine squared theta minus sine squared theta. And this can be over 1. So this whole factor, we take this here, cancels. And all that's left is cosine squared. And so I'm done. We say that this was just simplify. And this was simplify. Then I would... So I'll stop this video here. That was 70 and 83. And we will continue on another video with 84 and 86. How about 1 minus cosine squared theta minus cosine squared theta all over sine theta cosine theta. And I guess I would call that separate. So then this becomes sine squared theta minus cosine squared theta all over sine theta. And I think I'm getting toward the bottom of my screen here, so I'm going to stop writing reasons since this is just exploring another method here. I already did my proof up here with my reasons. This is just trying to start on the left side and get to the right in case that's how you did it. Then I would use that trick of separating the fractions into 2 terms. So there's the first term minus the second term. And then I think it will work from there, because this sine theta will cancel out the squared here, so you'll have sine theta over cosine theta. And then this cosine theta will cancel out the squared here, so you'll have cosine theta over sine theta. And I think I have just enough room to put in tan theta minus cotan theta. So there's an alternative method. Instead of coming up with this key little feature here that made this problem a little easier, you also could have separated this 1 minus 2 cosine squared to begin with. You could have just said 1 over sine theta cosine theta and 2 cosine squared theta over sine theta cosine theta. I think that would have worked. Not quite seeing it all the way through, but that would be something else you might try. So pretty tricky, but much easier if you start on the right. In general, I think it's easier to start with 2 terms and go to 1 term than it is to start with this one big fraction and get into 2 things, adding or subtracting. I think it's a little less intuitive that way. All right, good luck.